On to part 2, where we're just going to make some t-tables and plot some points. The Desmos activity, again, that's on the very beginning of the worksheet for today, kind of takes you through and lets you sort of discover which shapes these might make. I have already plugged in all the radian measures, and it's just the radian measures going around from 0 to 2 pi. And then I've plugged in the answers on a few of them. So that's what dots are plotted over here, just to save us a little time. So let me just make sure I show you, pi over 6, how did I get that? Well, the equation says r would equal 4 sine of pi over 6. And the sine of pi over 6 is a half, so the r is 2. This guy would be r, which, why don't I go ahead and put 4. The sine of pi over 3 is the square root of 3 over 2. And if you get the decimal, you get about 3.5. And so that's what I've plotted here. So let's just see 0, 0. Pi over 6, walk out 2. Pi over 3, walk out 3.5. Pi over 2, walk out 4. So let's go get 2 pi over 3. So r is going to be the sine, 4, times the sine of 2 pi over 3. That's going to be positive. And the sine of pi over 3 is my reference angle, square root of 3 over 2. So it's the exact same answer as when I button push this, I get 3.5. So at 2 pi over 3, I'm going to walk out 3.5. We already did 5 pi over 6, walk out 2. Let's do pi. So pi is going to be 4. The sine of pi is 0. It's going to be 0. So at pi, we don't go anywhere. Okay. Now look what happens when we start again. At 7 pi over 6, so here we go, the angle. 7 pi over 6 is right here. Whoops, let me stand on the pole. But we're going to walk away 2. So rather than coming out the terminal side of 7 pi over 6, we're going to walk away from that terminal 2, 1, 2, where we already have a dot there. 4 pi over 3, we'll walk away 3.5. So it turns out from here to here, it's repeating. And if you remember, sine is periodic. So there is a point where it repeats its values. So we now, again, I don't need to fill in the rest of that. If you want to, I'm just going to say that's -4, that's -3.5. It repeats itself. So what I get, if I connect the dots, I have a circle. The radius is 2, and the center is at 0, 2. And I could change this to rectangular. We've done this exact same one before, so I wasn't going to do that just yet. One of the nice things to notice, that it is symmetric to the y-axis. Okay, but I'm finding it just by picking points. So now let's move on to this guy. So once again, I've already kind of given us a bit of a head start. So at 0, you would walk out 3. At pi over 6, you walk out 4.5. At 5 pi over 3, at pi over 2, it's 6. So let's go get 2 pi over 3. So according to this, we're going to do 3 plus 3, and the sine of 2 pi over 3 is a positive 1/2. So if I add that up, I get 1.5, 4.5. Nope, I'm sorry. That is incorrect. That's, sorry, good thing I caught it here. At 2 pi over 3, my sine is the square root of 3 over 2. I had the wrong value. It's my wider. So now if I add all that up, I do get 5.6. Let's do the 5 pi over 6 one. So r is going to be 3 plus 3. The sine of 5 pi over 6 is positive, And at pi over 6, the sign is 1/2. There's the 4.5. Okay. And again, I did these numbers here. Let's do this one. R is 3 plus 3, the sign at 5 pi over 3, so it's going to be a negative. And again, at pi over 3, we're talking square root of 3 over 2. Add that up on that calculator and I get 0.4. Last one, if I put in that 5 pi over 6, or sorry, 11 pi over 6, actually the same value, different sign, 3, negative 1/2, I get 1.5. All right, so let's finish plotting the rest of these points. Sorry, did you see the bottom there? I wasn't paying attention. All right, so let's leave off. We went to 2 pi over 3. So here's 2 pi over 3. Terminal side, we're going to go out to 5.6. Okay. 5 pi over 6, we're going to go to 4.5. 1, 2, 3, 4. Sometimes it's hard to see. 0.5. There we go. At pi, we go out 3. Got it. At 7 pi over 6, we're going out 1.5. At 4 pi over 3, we are barely moving. At 3 pi over 2, we are at 0. At 5 pi over 3, we're barely going out. And at 11 pi over 6, we've got 1.5. Did I get on the right line? There we go. All right, so connecting those dots, I started that, where did I start at? 0, 3. Come around, come around. And if I did 2 pi, I'm back to 3. Okay. So this guy is called a cardioid because it looks like a heart. And how you can tell it's going to be a cardioid, there was a general equation. It can either be sine or cosine. And if your A and B are equal, you have a heart-shaped. If this was cosine, then our heart, if it was cos, then our heart would go this way. Oh, that's not a very good heart. It looks more like a Pac-Man. All right, so sine goes up and down with the y-axis. And again, it is symmetric to the y-axis. All right, so that's all I'm having us do today. The Desmos activity is going to be it's interesting. Even I learned a little something as I was doing it. And then you are strictly going to be doing graphs, a little bit of review as we did on part 1. And then our graphs, I've got sort of a table made, and you will be perfectly fine if you put in the values from 0 to 2 pi that are on the polar graph and just plot the points. And of course we convert to decimals so that we can actually plot points. All right, that's it for this week. Just beginning of 10.8. We'll do a little more with 10.8 next week. But I am pushing out a WebAssign on Thursday. And if there's AP test issues, just email me. Good luck for those that are still taking stuff this week with the AP testing. Take care.